Hello, today we're going to talk about domain and range. So let's look at and review what domain and range is. So the domain is a set of x values, is the range is the set of y values. So for domain, we have to look at how wide the graph is going to get, and then we're going to identify if there are any restrictions. So we're looking from left to right only. Your x-axis is what you should be focusing on. For the range, we are going to look at how tall the graph is going to be, and we're going to identify if there are any restrictions. So basically, we're looking from bottom to top. So here, I put a hint here. If your graph has arrows, then that means that the graph is going to continue forever in that certain direction. Okay? So we have to keep that in mind. So let's look at some graphs. Let's look at the domain and range of some graphs. So if we look at this graph, let's pay attention to the arrows. So we see here that this arrow is saying that I'm going left and up forever. This arrow is saying that I'm going right and down forever. So remember, domain, we look at left to right, and then range, we look up and down or top to bottom. So if I'm going left forever and I'm going right forever, I'm going in both directions forever, which means that my domain is all real numbers. I can be any number. The x value can be anything. The sign for all real numbers is a double-sided R. I do the same thing. I'm going up forever and I'm going down forever, so that my range is the same thing. All real numbers. All right. Now let's look at number two. Number two, my arrow here is saying that I'm going left and up forever. My other arrow is saying I'm going right and up forever. So domain is left to right. Left forever, right forever. All real numbers. Right? My range is going up forever and up forever, but up from where? The lowest part of this graph is at a -5. So that is saying that y has to be greater than or equal to -5, because that's the lowest point on that graph. All right. So that is my domain and my range. Let's look at number three. Number three, we see one arrow. We are going left and down forever. So domain, left forever. Well, if I say I'm going left forever, where am I going left from? If you look at this closed circle right here, if you go down to the x-axis, this x value is a 2. So basically, I'm saying I'm going left forever from 2. So that means that my domain is saying that x has to be less than or equal to 2. My range is saying that I'm going down forever. I'm going down forever from where? If I look at that closed circle at the top, I go to that point. That's the highest part of the graph. So if I count up, that puts me at a +4. So here my range is that y range has to be less than or equal to 4. So that is my domain and my range there. If we look at number 4, yes, I do see that I have these arrows. However, what I also see is that we have an oscillating motion. The word oscillating means to rotate. It goes back and forth, back and forth, back and forth. So I only go up so high and I only go so low. Okay? So I already know that based off of this, I know that my domain is I'm going to keep going left. So I'm still going left forever. And I'm still going right forever. I'm just bouncing in between two y values. Okay, so once again, left forever, right forever. That's all real numbers for the domain. All right, now let's look at the range. The range is how high and how low you can go. The lowest point on this graph is at a -2. The highest point on this graph is a 3. So I know that my range has to be in between -2 and 3 included. And make sure you put your less thans, because when you have two boundaries, If you have a lower bound and an upper bound, the lower bound comes first. Okay, so I know that y has to be in between -2 and 3, and -2 and 3 can be included. Okay, let's look at number 5. Number 5, I don't have any arrows, so I'm just going to have to pay attention to my axis and what's included versus not included. I'm going to go to the leftmost part of my graph, and I'm going to go to the rightmost part of my graph because I'm looking at the width. So this value here, this x value is at -3. This x value is at a +3. Okay, so as you can see, this x value, -3, is a part of that open circle, so it cannot be equal to because it's not included. So that means -3 has to be less than x, which is less than or equal to a +3. Now remember, I can be equal to this +3 here because this is a point. This is a point here on the graph, and it's not an open circle. So I know that that can be included. So that can be equal to. Now we do the same thing for range. You go to the lowest part of the graph, mark it on the y-axis. Go to the highest part of the graph, mark it on the y-axis. Right? So we know that the lowest part of this graph, and it is a closed circle, is at a -1. And we know that the highest part of this graph, which is still going with that open circle, is at a +5. 1, 2, 3, 4, 5. Okay, so that means that so the range can go from -1 at the lowest, and I can equal -1. It's a closed circle. I can tell that it can go all the way up until it get close to 5, but it cannot equal 5 because it's an open circle. All right, let's look at number 6. We are dealing with all closed circles, so we should be dealing with equal to's. So if I go to the leftmost part of the graph, that's here, that's going to put me at a -5. I'm going to go to the rightmost part of the graph here, and that's going to put me at a +4. So that I know that my domain is going from -5, x can be in between and equal to those two numbers, -5 and 4. So x can be in between -5 and 4, including those two numbers. So now I'm going to look at the range. I go to the lowest part of the graph and mark. I go to the highest part of the graph and mark. This is at 3, and this is at -5. So I can say that my range is going from -5 to +3. And I can put equal to signs because those are closed circles. Okay, so that is my domain and range there. So now let's look and see what we do when we actually have equations. Okay, when we have equations, what you want to do is you want to look for restrictions within the function or graph it in the TI-84 and then look at the graph. And you can also look at the table as well. So let's pay attention here. So if we look at number 7, we have this equation. One thing that you should see is that we have a square root. And we should know that you cannot take a square root of a negative number. So if we think about it, we want to see what does the x have to be to make this part in the square root? What does the x have to be to make that circle part negative? Because if it's negative, we can't take the square root of it. So basically what I'm saying here is that because all of this is under the square root, I know that x plus 4 has to be greater than or equal to 0. It has to be 0 or a positive number. So if I solve that, I know that x has to be greater than or equal to -4. So that is my domain. X has to be greater than or equal to -4. Now for my range, if I were to graph this in my calculator, the square root of x plus 4, and I look at the table, and let me change my table settings, second window, I want to start it at 0. So here, if I change my window, if I scroll up, you will be able to see that once I go from -4 to -5, I start seeing an error. So that lets you know that x has to be -4 or higher. You can actually see that physically in the table. In the same tone, you actually see that y has to be 0 or be higher. And you see that that's true because if you look at the graph, you will see that x is -4 on up and then y is at 0 on up. So here we know that the range is going to be y has to be greater than or equal to 0. All right, let's look at the next one. We have 1 over x plus 4. So the first thing I want to do is I want to graph this to see what's going on. One thing you should notice is you see a graph that kind of looks like this and a graph that kind of looks like this. You don't have to write this down. I'm just showing you. What happens here is that you see there's a break in the graph. This green break is like is called a horizontal asymptote. This orange break is what we call our vertical asymptote. So that's basically saying that there's a hole in this graph. So y cannot be equal to whatever number that green line passes through, and x cannot be equal to the number that the orange line passes through. Okay, so we have to use the calculator to find those values. So if we look here, if I go to the table, I can see that x can be any number. As you can see, every x value has a y value, no matter how negative or how positive you are, except for -4. So here I can tell that my domain, and once again, we already know that because one thing that we do know, one number you can't divide by is 0. So if I ask myself x plus 4 is equal to 0, that means that the x value that's going to make that 0 is -4. So that means that x can be any number, but it can't be -4 because if I divide by 0, it'll be undefined. So here, the way we write that is x is going to be any number such that, that's what that vertical line means, such that x cannot be equal to a -4. If you want to, you could write it and say all real numbers except x cannot be equal to -4. I don't care however you write it, as long as it's saying the same thing. It must be saying the same thing. It makes sense. All right, so now let's look at the range. All right, my range. If I look here, if I look at the graph, it looks like that the x-axis is where if we keep going to the left, the graph is going to get really close to the x-axis, and if we go to the right, the y value is going to get close to an x-axis. So if you look here, if I go to second trace, okay, I'm just going to say second trace anything. I don't need to find anything. I just want to trace on my graph. So I'm going to go to second trace, and I just want to move along the graph so that you can see it. So I'm going to choose, let's say 2, just for the point of it. So if I scroll all the way to the right, you see that those y values are getting really, 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 really close to 0. They're getting really small. Same thing will happen if I go all the way to the left. Okay, so I'm going to the left, to the left, to the left, to the left. And I'm going to keep going until I see it jump over. So as you can see here, as I go to the left, you see how those y values are still getting closer to 0. They're just getting closer to 0 on the other side. And as you can see, I'm still getting closer to 0. Right? So my range is basically saying the same thing, except y can be any number as long as y is not equal to 0, because that's where my break is in the graph. If you don't like that, you can say all real numbers except y cannot be equal to 0. Same thing. That's my range. All right, for number 9, we have the equation 5 over the square root of x plus 4. So once again, we know that we cannot divide by 0. And we also know that we cannot take the square root of a negative number. So I have two conditions here. So I know that x plus 4 cannot be negative. So I know it has to be greater than or equal to 0. And I also know that the square root of x plus 4 as a whole cannot be equal to 0. So let's look at the first inequality. So if I solve, that means x has to be greater than or equal to negative 4. Here, if I solve this equation, I am going to have to square both sides. So that's going to give me x plus 4 is equal to 0 when I square both sides and I subtract 4. So I know that x cannot be equal to negative 4. Okay, because if I have negative 4, that's going to give me 0. All right. So basically, I know that x equals negative 4 is going to make me 0, which is going to put me in violation. And I know that with the inequality, I can't take the square root of a negative number. So I have to put both of those parts in. So when I look at my domain, and I also can look at this graph as well, I know that my domain has to be, remember, you can also look at the table. So if I look at this graph, I see where x is negative 4, and it can be anything higher than that. If I look at my table, you can see here that when x is negative 4, I get an error. So that means x can be very, very close to negative 4, but it cannot equal it. So that means that my domain is that x is going to have to be greater than negative 4. I can't be equal to it, but I can be really close to it. I can be negative 3.99999. So my domain has to be x is greater than negative 4. And then my range is saying how high and how low I can go. So my range, the highest y value that I see, because remember, I get errors up here. The highest y value that I see is 5. And if I look at the lowest y value that I see, if I keep scrolling, then I see that these numbers are getting very, very close to 0. Or if I want to go to my second window to go to table settings, I can tell it to start when x is 100. And I go back to my table. And as you can see, the numbers are getting really small, close to 0. Go to second table or go to second window. I'm going to say I want it to start at x 500. As you can see, I'm getting really, really close to 0. If I go to second window, I can say 2000. Go back to the table. And as you can see, we're getting really, really, really close to 0. So here I can say that my range, the 0 is going to be the smallest number, and it's not going to be equal to 0. It's just going to get close to it. So I can say 0 is less than or equal to y, which is less than or equal to 5, because that is that is the highest y value. Okay, so that'll be my domain and my range for that one. If you have any questions on domain range, please ask your teacher, and have a great day.